So as I was saying, today we're going to hear from three speakers who are all working in robotics. And the field of robotics comes under the overall field of mechanical engineering. So just to give you a little reminder about mechanical engineering, I posted these slides to the module for this week. So if there's anything you want to review that I skip over, please feel free to take a look at those. What do mechanical engineers do? Well, mechanical engineers, as you can see on this slide, combine a lot of creativity, knowledge, and analytical tools to bring an idea into reality. And you can see the kind of tools they use and how they make that happen. Mechanical engineers have an enormous range of opportunity, and their education takes into account a whole bunch of different subjects. There are a lot of subdisciplines of mechanical engineering, and you can see the list here. Today we're going to focus on robotics and mechatronics through our guest speakers. But I think, if you're interested in hearing about more of these fields, I can tell you a little bit more about them later in the class, just in the interest of giving our speaker their speaking times. I'm going to skip over it, but you can see there's a lot involved in mechanical engineering. These are some simple examples of things that are designed by mechanical engineers. And it's just actually 6 simple examples. There's quite a few more that are out there. And really what's more interesting is what the future of mechanical engineering holds. Here again are some examples of some of the fields that mechanical engineers work in and the kind of things that they work on. And some of these you know already, like automobiles or HVAC or manufacturing, space engineering or space research. I think we know that because we spoke with our aeronautical engineers and aerospace engineers. Biomechanics, though, this is actually one that's an emerging field, along with nanotechnology. I know you heard a lot about composite materials when Carl talked about materials engineering itself. You'll hear more about robotics, and you've heard about aerospace. So the 2 things you may not have heard about are biomechanics and nanotechnology. And nanotechnology is engineering on really small scales. And you may have seen items of nanotechnology already out there. But this is a field that is actually growing, trying to use tiny, 10 to the minus 9th meter size machinery and stuff like that in engineering applications. And not only in engineering applications, but in medical applications, things like that. So this is a field that if you're interested in and you're interested in mechanical engineering, there's a lot of growth opportunities there. Also, we have biomechanics, which applies mechanical engineering principles to biology, essentially. And you can see the emergence of this technology in things like prosthetics, robotic exoskeletons that assist people with muscle weakness, and other mobility issues, and even brain research or improvements in medical imaging, or even, think about this, printing human organs with biomaterials through the use of something like a 3D printer. So a lot of exciting work that is coming out of mechanical engineering. So with that, I will stop. That's all I wanted to, kind of give you a preview of what's out there, and turn the Zoom over to our first speaker, who is, there he is, Hector Luna Ramirez. He is a former Cabrillo student who went to San Jose State. He has a bachelor's of science in mechanical engineering with a mechatronic focus, and he works at Magic Leap now, which is a startup. So let's welcome Hector. And Hector, why don't you tell us a little bit about the work you're doing, and maybe the students could ask some questions too in the time we have.
Okay, can you hear me fine?
Yeah, we can hear you.
Okay, so I am currently mechanical engineering on the rapid prototyping team in Magic Leap. Our team focuses on internal facing customers. So what we do is we take requests from other teams within the organization. Such teams could be people that are focusing on gestures, on world reconstruction, stuff like that. So we take in their requests. Sometimes they need to collect a lot of data and we need to create fixtures. So our job is to rapidly create fixtures, usually involves 3D printing parts, laser cutting, water jetting, just, trying to do one-off custom stuff as quickly as possible, just to aid our internal facing customers to help better their algorithms. So say one of the things we help out with is a head pose. Head pose is what our device does is it uses cameras to read in, it takes a bunch of pictures and it's able to locate itself within the real world. And when you want to put a virtual object, say on top of a table, and once you place it on top of a table and you walk around, maybe go to a different room and come back, you want the object to be in the same location on that table. So what our team does is we build a lot of some software tools and a lot of like hardware tools to help them improve their algorithms to make sure that the objects stay where they're supposed to stay. So we work a lot with robotics also. We use robotics to do automated data collection as well.
Do you have any photos of the work you do or examples?
We're not able to share those.
Oh.
Yeah, there's a whole bunch of like NDA stuff, but yeah, I could only really go over some generalized stuff, but yeah.
So Magic Leap doesn't have a website?
It does, but none of our internal facing stuff is really on there.
Oh, interesting.
So you are able to see like reviews and stuff because our device is already out on the market, the ML1. So you could check out reviews and stuff.
So we should look up something called the ML1 if we want to see what that looks like.
Yeah, from Magic Leap. It's pretty much, I don't have it here, but it's kind of like large glasses that go over your head and they have a little, it looks like a hockey puck computer that you place on your belt or your pants. And
then what do you do with it?
It has a lot of different applications. Currently, right now, we're looking into more enterprise focused applications, but in the past, it was consumer focused.
I'm gonna share my screen because I brought it up. Yeah.
You could play Angry Birds. You could do. They have a whole bunch of different user experiences. The software that's on there right now, it's a wide variety of applications. It was kind of more of like how to show all the different things that we could do with the device.
Cool.
So it wasn't very focused, but we do have a lot of cool things on there.
Wow. And Hector, I know you have an interesting story about your transfer from Cabrillo to San Jose State. Could you talk a little bit about that?
Yeah. So for my transfer,
you just stop the Quizzy. Come here, Quizzy. We love beating up boyfriends.
Could you guys mute yourself? Okay.
Yeah. Oh,
yeah.
To answer the quick question, the device does not have LiDAR cameras, but we do use LiDAR in data collection. So there's a little bit more information. So my transfer, I did not go in. When I went into San Jose, you get your application gives you 3 choices of majors. my first choice was mechanical engineering. Second was materials. Third, I forgot what I put for third. But if you don't get into your first one, they don't automatically apply you to your second choice, which to me doesn't make sense. So I became undeclared when I went into San Jose State. And once I became undeclared, I had 3 tries to apply to the mechanical engineering college. The way, at least when I did it, the way you go about it is you take a few mechanical engineering classes or general engineering classes, and you add you write in a form, I think it's up to a couple of units. I forget how many units, but you write in the form and you petition to get added. So pretty much they're looking at how you performed in those engineering classes to see if you're gonna work out as an engineer in that program. The hard part is all the classes. Since you're undeclared, you have to add all your classes on the first day of school. So it's a lot of it's kind of stressful jumping around trying to see what will fit your schedule. So right now, mechanical engineering, as far as I know, is still impacted at San Jose State. So if you don't have a very high GPA, more than likely you will be going in undeclared or trying to add it. My advice is keep trying, get friendly with some of the professors there. Nicole Okamoto, she's really cool. So I would recommend talking to her. She's an advisor and she was a lot of help to me when I went there to San Jose State. So yeah, and one of the things when you transfer over to San Jose State, they're not as friendly or as caring as in Cabrillo. They see a lot of students, so you kind of end up getting lost in the sea of all the people there. So try to make sure you talk to the teachers and get them to recognize your face and your name, and they will more than likely help you out.
And I think some of the advice you just gave is relevant at every school, that you should get to know a professor, regardless of where you go. You should get to know the teachers there. It would really help.
Yeah, and one of the other things too is what is it? Rate Your Professor. .com, if that website is still going on. Yes, it's very good to check that out. I know there was a lot of classes that I avoided because I heard of how bad some of the teachers were. So I was really focused on making sure that I learned the materials. So yeah, I would suggest that if possible, skip, use that as a reference. But yeah.
Yeah, and as from the professor side of things, I would say don't use it as a reference, because there are a lot of vindictive students that will just write horrible things about you, which are not true as well.
That's true.
So I just think it's worth knowing both sides of that. But one of the things that I was hoping you could talk about was, I think you said something about you only get 3 chances to transfer into your major. Is that... Was that true? Was that something you said?
Yeah. From my experience, we had three tries. You get 1 try per semester. So you take.
Hector, we lost you.
So it took me. I think I got in on my 2nd try, but I had a friend who was not able to get in on his 3rd try. And unfortunately, he ended up dropping out, and he wanted to go to a different college, and I don't think he ever ended up finishing his degree.
We lost you for a second there, but I think you came back in when you said you got in on your 2nd try.
Yeah.
So we missed what you said before that.
Okay. Yeah. From my understanding, you do have 3 tries, and it's usually 1 per semester.
Uh-huh.
I think you get 9 or 12 units that you're able to fill in on that form. It's pretty much a form that says, with these classes that are engineering level, this is kind of the grade that I got, kind of, verifying that you can keep up with the material.
So So transferring from Cabrillo to San Jose State sounds like you apply. Well, there's the automatic process that you can qualify for, right?
When you transfer, if you meet their prerequisites, you'll get in as a mechanical engineer. But most colleges, well, at least San Jose State, it's impacted. So if you don't have the high GPA, you won't be able to get in. You'll get in as undeclared.
Okay.
Yeah, so that's what happened to me. So I just had to keep on taking classes until I got in.
Oh, wow. Interesting. Okay. And after San Jose State, did you go right to Magic Leap?
No, I worked at 2 smaller companies before that, and then I went into Magic Leap. For those, there's different roads that you could take. I went into the smaller jobs because I kind of wanted more experience, and they were easier to kind of get into. Unfortunately, in smaller jobs, you wear a lot of different hats, and it's a lot of responsibility and stress. It's fun, but after a while, it gets tiring. So I would definitely recommend, there's different things that you could look out for, different signs of, definitely try to go for a company that has a good environment that looks to try to take care of its employees. One of the telltale signs is looking at how long most of the average employee stays there for. If it's a company that has a high turnaround, there's probably a reason. It could either be they don't compensate their employees enough, or there's just, management or, different things that could be an issue. And also look at how they treat, especially like their older employees. I was worked at a company where the guy that was there for 11 years, they did not treat him very well. So I looked at that, and you look at that and you think, is this what I'm striving to become? And for me, that was a no. So that was one of the reasons I left. Having a good environment is, at least for me, it's very important.
So there's a few questions in the chat. And I also wanted to ask you if you could explain how you figured out that company wasn't nice to the older employee. And I think the question in the chat, is there a website to check a company's turnaround rate? And what's it like being part of a startup? Is it a better or worse experience than a regular job in your experience?
Okay. I guess, let's see. So for being at a startup, the nice thing is, kind of being surrounded by the tech companies. And Magic Leap does have a lot of software engineers. So, you have a lot of competition. And so Magic Leap has to cater to those employees just as good as like a Facebook or Google does. So they do tend to take care of their employees a lot. So you have like, we have unlimited PTO. We get snacks, drinks and stuff. So it's really nice. Magic Leap is a little bit different as a startup because they got a lot of money and they're a very large company for a startup. So I would say it's fair. It's somewhat stressful, but it's very fun. A lot of startups have a lot of younger employees. People trying to set out and make their mark in the Silicon Valley. Both can be good and bad. Since I imagine most people are, we're fairly close to Silicon Valley, so I would recommend definitely checking out, one of the startups. It's a fun experience either way. And
when you say Magic Leap is large, what does that mean? Like as a startup?
Most startups are less than 20 people, like when they first start out, and then they start growing. Magic Leap currently, I think, is about 1,000 employees worldwide.
Oh, wow.
Yeah, so for a startup, it kind of doesn't really fit some of the criterias for a startup.
Right.
I would recommend it. I would recommend getting a job in the tech industry just because of how much a lot of companies are kind of fighting to be the next place that people want to work at. So I would definitely go for that.
Do you find that you use the skills you learned at Cabrillo and San Jose State in your job every day?
Yes and no. You know, we don't, for at least for my team, since we do things kind of fairly quickly, you can't sit there and do kind of FEA analysis on everything that you design. You kind of have to go towards experience and intuition for that. But one of the things that you do learn a lot is all your communication skills. You know, I remember when I was an engineer, I was thinking, why do I have to take communications for engineers? I thought that was a stupid thing, but it actually is not. You know, you end up working with a lot of different people from different backgrounds. Not all people are technical. Not all people have English as their first or even second language.
Wow.
So having things written and documented well not only protects you, but it also helps, you know, it helps you if you have to go back to the project later on. And it also kind of helps you if you need to show someone else how to do something. So it's actually very important. Also, in terms of like senior projects or student projects, if I had one where we documented and we videotaped our project working, and the next day during before our presentation, it broke. So we couldn't really show the instructor that it was actually working. Luckily, we did have a video of it working.
Oh.
So that really saved us. So I highly recommend whenever you get something working, take a video of it, just so you have proof. And to get to the other question about the website that checks company turnaround rate, I think it's Glassdoor. It might have changed a bit. Back in my day, it was a little more open-ended, but Glassdoor is what I used. It helps you get a good idea of like, you know, people will post the different positions they have and the salary that they get. There's also other websites where you could check, you know, the average salary of your position with your degree with your amount of years of experience. Like if you're a mechanical engineer with 2 years of experience, you should look for X amount of money or X amount of dollars for that rate. So that would be a good website. LinkedIn, I think, also has some good stats on the jobs that they post. So I would recommend also looking at other jobs with similar criteria, just to look at you know, what kind of things you should look for.
Yeah, I think Clayton had a question, but it might have been, what is the website? And I can type it in. Go ahead, Clayton.
Yeah, I actually had two, if that's okay, just real quick. Was
Yeah.
that Glassdoor.com, first of all?
Yeah, I believe it's Glassdoor. I'm not sure if it's still around, but it was when I was looking for my jobs.
Is that a good website to check a company's turnaround rate? Was that one?
Usually they did, I think they did have some there, but also in interviews, don't be afraid to ask questions like that.
Okay.
Because, you know, you're not only the person being interviewed, but you want to make sure that you're interviewing the company. You know, ask about if they have team activities, ask if they have, you know, what kind of vacation times and stuff like that. So I think that was my mistake with my first few companies that I worked for. My first two is I didn't really interview them as much as they interviewed me. So definitely don't be afraid to interview them, because hopefully you'll be with them.
We lost you for a second. You said hopefully you'll be with them
for a couple years.
Okay.
Yeah.
Yeah. Thank you. Does anyone we have one more minute with Hector. Does anyone have another question they want to ask?
That AR glasses set use like a LiDAR camera?
No, it uses 4 just black and white cameras and a depth sensor. We do use LiDAR for other things, for like ground truth. So one of the methods we're able to verify that the device reconstructs the environment correctly is we have other cameras that kind of do higher end measurements that, you know, you're able to verify that the device is at the position that it thinks it's at. So yeah. We use the same cameras like in video games and movies where the motion tracking cameras.
Oh, yeah.
Yeah.
Okay, well, thank you so much, Hector, for joining us. It was great to see you and hear about the work you're doing.
I think there was one more question in the chat is asking if, I think they sent it privately, but is it the same transferring to other engineering disciplines in San Jose State? And as far as I know, the process is the same for all engineering colleges. The only difference is they're probably not as impacted as the mechanical engineering. San Jose State is fairly impacted with mechanical engineering.
Thank you so much, Hector. And if the students have more questions, can they get in touch with you?
Yeah, I'll post my email in the chat.
Okay, that would be great.
All right, no problem.
Okay. Our next speaker, who has also already joined us, is Johnny McCullough. And he was born and raised in Santa Cruz, went to Cabrillo College, and transferred to UC Santa Cruz, where he got his bachelor's degree in robotics engineering. He has worked for Fox Suspension, Apple, and he's now at an autonomous vehicle startup called Aurora Innovation as a hardware reliability engineer. And fun fact, he met his wife at Engineering 5 at Cabrillo, actually. So I think you're the second husband-wife couple we've had in this class, Johnny.
Oh, is that true? Is there another?
Yeah, we had a couple from civil engineering join us a couple weeks ago.
There's something about engineering and romance.
So, Johnny, do you want to talk about, I know that you had a lot of advice about your internships and some of the work you've done. Maybe you could start with that.
Yeah. So while I was actually going to Cabrillo, more than a decade ago now, it doesn't seem like that much time has passed, I was able to land an internship with Fox Suspension, which was really cool. So I was still going, doing my physics classes at Cabrillo, going through math, going through a lot of, like statics and dynamics classes, but was pulled in for this internship in their test lab. So got to basically see all the different products Fox makes as a suspension company. So all the suspension products would come through the test lab and would have to basically come up with different ways to test these things as if they're going to be used in the field and really beat up on them to make sure they weren't going to fall apart for people that were riding mountain bikes or driving in their off-road vehicles. So the really important part of the product development work there. And that's where I was really introduced to mechatronics. So this idea of kind of fusing mechanics and computers. And I was really, when I was at Cabrillo, I was really leaning towards either like a civil engineering degree or more of a mechanical degree. But kind of once I got my hands on embedded systems, like Arduino was starting to get really big back then, any sort of microcontrollers, and kind of using those and applying those within the test lab at Fox. It really kind of steered me towards wanting to do this this mechatronics degree that had a little bit of everything in it. It had some EE, some ME, computer science. It was really was really more of a generalist kind of degree that I just connected with. So that was my push to go to UCSC. It was kind of convenient. I could continue to work, and yeah.
Do you think Cabrillo prepared you well to jump into a degree that combines so many things, like electrical engineering, mechanical engineering, and stuff like that?
Most definitely. Yeah, I mean, all the foundational stuff is really important for any engineering degree. And they all kind of, even as you specialize, you get deeper into electrical engineering or mechanical engineering, there's, analogies that run across, circuits and mechanics and inductors and dampers and that kind of thing. So yeah, all the foundation that I took away from Cabrillo was amazing. You're learning stuff in relatively small class sizes that at a university would likely be learned in an amphitheater with hundreds of other students, where it gets a little more impersonal. So yeah, having some of these smaller classes at Cabrillo, and the curriculum is really second to none from my experience, just from what I experienced at University of California, and then what a lot of other friends experienced who also went to Cabrillo, who went, traveled across the country, different schools.
That's great. And where are you working now? Oh yeah, what are you working on in your current job? Because I think everyone would love to hear about your experience at Apple before you got to your current job, actually.
Yeah. So one of my coworkers from Fox, who was turned into a good friend, got kind of poached out of Fox for this kind of secret project that was being worked on at Apple at the time. And he took off, and I ended up connecting with him maybe a year or so later. He'd reached out and said, "Hey, how would you like to work on, this kind of crazy thing Apple's doing?" And I was like, let's check it out. So I got pulled over and interviewed, and it was really like, they're very secretive about stuff to a point where it's a little silly, but went through this basically an all-day interview. A new interviewer comes in and kind of grills you for an hour, and then another one for an hour, another one for an hour, and by the end you're just exhausted. But yeah, they gave me an offer, and I was like, yep, got to check out what Apple's doing. And I got put on this kind of autonomous vehicle project that they're working on. It's still secret. Everybody kind of knows what they're doing, but they don't tell anybody. And it was just incredible. It was crazy to see what a company with basically all the money does with that money, and the resources they have to kind of attempt to solve problems. And it was really fun. I learned a lot. It was really like a deep dive into kind of Silicon Valley and Silicon Valley culture, from a kind of an old school company that Fox is, old school, I would consider engineering, to this kind of Silicon Valley. Everything moves super fast, and everybody's crawling to get their ideas seen and heard. And from Apple, there was a lot of pivots on that project. So there was a lot of changes of direction and what they wanted to do. And the upper team was constantly kind of shifting the idea of what this autonomous car project would be. And they ended up kind of getting rid of this product that we had all been working on for quite some time. And so they got rid of our test team, the reliability team. I guess I should explain what I was doing there. But so reliability engineering is basically, hardware reliability is making sure that the products being developed are going to be able to survive in the field. So for us, for an autonomous car, that would be, we're trying to put all these computers and LiDAR and sensors, cameras, radar, all this stuff in a vehicle that may typically not live on a vehicle. So different ways to harden these products and make sure that they're going to survive 100,000 miles, make sure they're going to survive out in the Arizona desert under extreme conditions that typically they're meant for, like server farms or something like that. So designing lots of environmental tests, coming up with countermeasures for, you know, certain silicon chips that are mounted to these boards need a certain sort of composite to go around it to hold it together. So I was doing all this reliability stuff. And they were like, yeah, we're not really going to make a product anymore. So they cut off like 250 of us from that project. And it offered me another role kind of with the main campus where they'd work on phones and consumer products. And it was going to involve me going over to China. So I didn't really want to spend 6 months in China every year. So I took some time and went around and interviewed at these other autonomous car companies. And I ended up really liking the team that interviewed me at Aurora. And I think their approach to kind of how autonomous cars are going to evolve into the future is really smart. And so now I'm currently there working on, you know, very similar endeavors. So they're making lots of hardware. They're developing their own in-house long-range LiDAR that I get to try to break and help robustify for kind of the future of autonomous cars.
Do you have to travel at Aurora?
Before COVID, yeah. Haven't been recently. We have offices in Pittsburgh, an office in Bozeman, Montana, which I've really been wanting to go to. I heard the skiing is really nice up there. And then one here in San Francisco.
I think someone is asking why you didn't want to go to China. Like, sounds pretty exciting to this group.
Yeah, I think for me, I had done a bit of traveling for Fox and really enjoyed it. Got to go to Germany a bit, got to go to Italy a bit. And it was really cool. I would definitely love to go to China, but not spend 6 months over there. I would be in 6 months away from my wife, 6 months away, you know, from the family. So maybe if I was a younger single person, that might make sense to spend a lot of time over there, but it just wasn't something I was ready to do.
That makes sense. You talked about the work you did at Fox, the work you did at Apple, the work you're doing at Aurora. How would you compare working at those three different companies?
They've all definitely been quite different. Fox, you know, has been around since the 70s. They have lots of kind of momentum in the way that they do things. And they have these procedures that, you know, have been invented by an engineer who hasn't been there maybe for the last 10 or 15 years that we're continue to work off of. And there's lots of kind of like, this is how we do things. This is how it's done, which is great because you get to see how a product is taken from idea to basically manufacturing, production, and then out to a consumer. And, you know, they do that every year with new products in a really tight timeline. So it's incredibly impressive with a really complicated supply chain from Taiwan to the US. But so those processes are pretty much solidified, and it's like, this is how we do things. Going to Apple, I'm sure on the main campus is very similar in that sense, but on the special project, it was kind of like, nobody's made an autonomous car. Nobody knows how to do it. Nobody knows what the correct hardware is to pick. And so we were making up a lot of things, you know, as we were there, like, oh, this sounds like this is how we should do it. We should, you know, use some engineering judgment, come up with some calculations to justify why we're doing certain things, but it was all new. And that can be really exciting and really stressful because, you know, you always kind of second guess yourself. And now you're part of the engineering group that's coming up with, you know, maybe how things will continue to work into the future or not. And then moving to Aurora, which is not backed by, you know, a giant like Apple. We have a good chunk of venture capitalist money, you know, from Jeff Bezos from Amazon gave us some money to see this thing through, and a handful of other big funding giants kind of in Silicon Valley. But, you know, we have like a clock that's kind of ticking down and we have to, begin to show progress in a product. And so there's definitely kind of more pressure on at Aurora than maybe at a place like Apple or Fox that has a product that they sell and make. So we're not making any money. We're spending money. We'll continue probably to spend money for many years before we start making money. So that can be a bit stressful, but it's also exciting in the sense that, kind of like Apple, this is just, everything is very new, and I've taken on a lot of roles that I probably wouldn't take on in an established company, where I'm setting up the new test lab, just purchased $1 million worth of test equipment. And I'm like, are you sure you guys really want me to be speccing all this stuff out? I mean, we'll see. It can be nerve-wracking, but it's really fun. It's like you're learning, you're kind of put in the deep end and you're learning very quickly.
I want to let the students ask questions if they have any. I don't see anything in the chat, but if anybody has a question that they want to ask of Johnny, please feel free.
People at Apple kind of like robots, or are they real people? You know what I mean? I just imagine them as all like worker ants that have no personalities, but I know that's not true because it's run by humans. So, but what's it like? Like, do you make friends in there? Do they laugh? Do they smile? Do they like, do they fart? Do they eat? What do they do?
That's a great question. I think going in, I was kind of assuming the same thing. I was like, is this just a big corporate monster that, everybody's kind of zoned into what they're doing? But no, there's crazy creative people that are working at Apple. And I think it really just depends on what team you land on. I think you can find yourself, it's such a big company, there's like 100,000 employees worldwide. So like, I think you could find yourself in a team that is going to be super creative, enthusiastic, come up with really wild ideas. But you can also find yourself on a team that is robotic and is just trying to churn through things, and it could be completely miserable. So yeah, anytime you hear like maybe somebody who's worked at Apple who just says, oh, that place is horrible, or that place was incredible, it's going to be an incredible experience no matter what, like you got to take that with just a grain of salt. Your experience is going to vary, just totally dependent on the team you end up on. And it's something I think you kind of have to figure out jumping into a company that size.
Do you still keep in touch with coworkers from Fox and Apple?
Yeah, most definitely. Yeah, so whenever my current company, cuts me or crashes and burns in the future, it's always good to have a network behind you to be able to reach out to and see what's available. So yeah, I still keep in contact with, I still go play golf with a lot of friends I made at Apple. I still reach out all the time to friends and coworkers I made at Fox, some now that are directors at the company, which blows my mind. I'm like texting them, dude, what's up? You're the director now? This is crazy. So yeah, like continuing to keep people that you've worked with as part of your group and reaching out when you can is really important. And it keeps doors, keeping doors open really for your work life is important too.
Does anyone else have a question they want to ask? Okay. I guess the only other thing I was thinking is, like, how much of what you learned in college are you using on your day-to-day job?
That's a good question. More than I thought I would, honestly. Yeah, like plenty of times used, just a lot of it's coding. So a lot of coding classes I took at UCSC, I apply all the time. A lot of mechanics, just basic mechanics things. Materials engineering is pretty important for me, especially just talking about, you know, fatigue damage over a certain life of some small computer component. And statistics. Statistics has become very important. And the more I get into kind of this autonomous vehicle world, it pops up everywhere. So it pops up on the reliability side because we think of things in terms of how many modules are going to fail in the field if we have 1,000 trucks and they need to, you know, operate for 4 years. Are we going to see, you know, how many failures are we going to see? How much is that going to cost the company? And then they pop up in the sense that they're used heavily in machine learning. So when you're trying to do some sort of regression analysis to see how the input of some sensor affects kind of the perception and the tagging of maybe a person or an object in the road, a lot of it comes down to kind of statistics and what the computer most likely thinks that is. So yeah, understanding those things is paramount.
There's another question really quickly in the chat because Aaron is here. How does working for a company with unlimited resources and now working for one with probably not as many affect you? Any differences?
That's a really good question. So at Apple, there was always this joke that like we had a too much money problem. When you have too much money, you end up throwing money at the problem because that's seems like the quickest and easiest way to go about it. But what you can end up with is, you know, a lot of these, like maybe a lot of technology that you purchased that's very cutting edge, but only a very few, you know, a very small number of people are going to be able to utilize it at the company. So now you've kind of worked your way into a solution that, you know, might be a little bit better than another solution, but you've cut off a big portion of the company to be able to utilize that solution. It's kind of a small example, but we ran into that a lot. Like Apple would go down some road and burn a ridiculous amount of money doing it. And then all of it would basically be, okay, let's not do that. And it'd be wasteful, and it'd also be a bit of like a, you know, morale, just a real cut to the morale because everybody had invested a lot of time and work into doing something for it just to kind of be cut. And then whereas a company that, you know, has to care about profits and care about losses and things, you feel like you're much more in the real world when you're kind of talking about solutions. And you know, it's much more grounding, but there's definitely obviously pros and cons to each of those things. You know, having a ton of money and being able to get something done super fast can be definitely useful for moving quickly. But yeah, I would say if you can spend some time at a company that has to worry about, you know, a product they're making and there's profits and margins and things involved, that's definitely more of the real world than when you're at a massive company that can burn money like maybe Google or Apple.
Great. Thank you so much, Johnny, for speaking with the students. Yeah. It was
Thanks
great
for
to
having
see
me.
you again.
Please reach out if you have any questions. I'll put my email in the chat. And yeah, it's really exciting to be a part of this class, you know, 10 years ago and people going through it. And yeah, it's a challenging road, but you all can do it. I believe in you.
Thank you. And also kind of fun fact is our next speaker's name is Aaron Haggerty. And he too was an intern at Box Suspension. I think Johnny didn't mention that Johnny was the first intern they ever had and set up basically the entire internship program. And Aaron did that while he was at Cabrillo. And then he transferred to Cal State University, Chico, in mechatronics engineering, which they have a program as well. He's now at Amron Robotics and Safety Technologies in Pleasanton and works as an application development engineer in a fixed robotics lab. Aaron, are you here?
I am here. Good
Great.
afternoon. Good evening, everybody. Hi. Nice to see you. Johnny, nice to see you again. So yeah, as Pretty mentioned, I work as an application development engineer in fixed robotics. This is the robot I work on behind me. It's a 6-axis serial link collaborative style robot. What makes it collaborative is, as you can see, there are no safety cages, no safety cells around it, no screening, no fencing. I can actually work right next to that robot. And if I were to kind of bump it a little bit, there we go, a little bit harder, then it will error out. It'll basically say, hey, I'm sorry I bumped into you. Let me back off a little bit. So it's kind of an interesting time to be in robotics. These collaborative robots are really, really coming up in industry. They're very simple to set up and use, and people really like them. They're also a lot less expensive than traditional fixed industrial robots because of the lack of safety cages and cells that you need to provide with it. So it's pretty fun.
Cool. And tell us about your time at Cabrillo and Chico. I know that you had some interesting things that you were working on.
Yeah, so I grew up in Boulder Creek, Santa Cruz County, went to SLB High, graduated there, went to Cabrillo for a couple years, actually in business, and then decided I didn't want to do that. So I kind of, messed around for a little while and didn't really find out that I wanted to do engineering until later in life. What got me interested in it is just, being a hands-on kind of person, really liking it. And then seeing way back in, a decade ago about when I started the whole journey at Cabrillo, I could see that manufacturing in America was coming back and that robotics were going to be the way that it was going to happen. So knowing that this is the industry to be in way back then was really kind of a neat thing, because this kind of job didn't exist when I started at Cabrillo and knew this is what I want to do. I knew that it would be coming. So that's a little bit about my background.
Someone asked how old you were when you started your engineering studies. I don't think you have to answer. That's a personal question.
I was in my second life, let's say that. No, I was actually like 33, 34, something like that. I started in 2009 back at Cabrillo. And as I said, my first time through Cabrillo as a business major, and so I didn't have some of the math and physics backgrounds that I needed for engineering. So it took me a little bit to get through that. I'm not the best mathematician in the world. Like 5A and 5B and 5C took me more than one semester to get through each one of those. So it took a little longer than normal. But if you really just stick through it and you're really passionate, you want to do it, then it's something that you can get through, even despite setbacks. Just keep pushing, and you'll eventually get there.
Oh, and then could you tell us about your transfer to Chico State then?
Yeah, so my transfer to Chico State, I had some options. As you know, robotics is coming up in a lot of different colleges. Johnny went to UCSC and worked on robotics there. I was looking at that. When I first decided I wanted to get into robotics, I was thinking robotic prosthetics would be a really great industry to be in. That would be just amazing, right? And of course, at UCSC, they do a lot with exoskeletons. So that was really interesting to me. But being at Cabrillo for the length of time that I was, wanting to continue my process at a 4-year college, I would have needed an extra year at Cabrillo to transfer to UCSC because they're computer science-based robotics program, whereas Chico State is mechanical-based, and I had all the requirements fulfilled already. So I decided to shorten my experience by a whole year and just transfer straight up to Chico. Chico is one of only 3 or 4, a small handful of accredited degree programs, ABET accredited mechatronic degrees in the country, and one of only 1 or 2 west of the East Coast. I know UCSC was working on it. I'm not sure if they're there yet, but and also Cal State, Cal Poly Pomona, possibly. Other ones are like Carnegie Mellon, MIT, etc. So we're in good company.
Okay, and can you tell us about? I think you had about the clubs you joined and stuff.
Yeah. So let me go ahead and share my screen real quick, and I'll run through a quick slideshow. Screen free. Share. So this is my Baja Club. We build we design and build a single seat race car every year from scratch. It's all student led, student run, student designed, and student built. And then we race against 100 other teams from around the world. There's actually 3 competitions throughout the year. We typically go to the West Coast competition. It's around the same time as finals. So it's real fun trying to get a car ready and study for finals at the same time. But you learn, literally, you learn how to weld, you learn how to machine. We do all of our own design work. So I actually built the suspension on this car. You can see the component that this guy's working with here is all the white pieces on this car are the suspension components. So I actually designed, built, and fabricated all of those suspension components, which basically tells the car how to handle. It's a lot of fun. It really is the most fun I've ever had in my life.
How did you decide to join this club?
Yeah, that's a really good question. I knew, being from the Cabrillo Robotics Club and what that did for me, if you guys don't know about the Cabrillo Robotics Club, it's unfortunate that everyone's off campus right now because that club is really great. I actually started that club back in 2012 maybe. And their first national competition was a NASA Mars rover competition. They actually won that event. So Cabrillo Robotics Club is really doing some dynamite stuff. And knowing what kind of opportunities that presented me, I knew that a club is where you're at, right? That's where you get the hands-on experience. That's where you actually put into practice the things you learn in class. And that's what employers are looking for, right? Grades, yeah, cool, great. Everybody has the same classes. Everybody's done the same work. What kind of projects did you work on? You can either show somebody a piece of paper and say, look at all these studies I've done, or you can show them an actual project and say, look what I built, look what I designed, look what I programmed, right? So this is really the kind of thing that employers are looking for. Do you have hands-on experience? And there are about 20 engineering clubs on Chico State campus that run the range from robotics, mechatronic clubs with mobile vehicles, UAVs. There are civil engineering clubs. We have a bridge building club and a cement canoe club on campus. And then there's 3 car clubs on campus, an off-road club, Formula gas combustion, and a Formula electric club. And so at the beginning of every year, and most colleges do this, Chico has a fall and spring Meet the Clubs Day, right? Where all the clubs kind of go out in front of their buildings on campus, in front of their workshops, and let new students and prospective students come and look around and talk to club members and kind of look and get an idea of what's going on. So I did that first semester there before school started. I went up and I met all the clubs. The Baja Club was one of the few that was kind of had their stuff together. They were ready to go. They were ready to take new members, and they were ready to have their meetings. Everything was scheduled. Yeah, I think the Robotics Club would have been an amazing opportunity as well, but that club sort of got defunct. The leadership wasn't there, so it took a while for that club to kind of come back. Baja Club was ready to go. I love racing. I've never gotten a chance to race, so I knew this was going to be a great opportunity. And I was able to take my robotic skills and what I do with Arduino and stuff like that and actually make sensors for this car, right? So you do your design, you do your engineering, you do your testing, you write all your numbers, then you build it, and then you have to validate, this thing I build match what I intended it to be. So putting sensors on this car and actually taking that data off the vehicle was, a huge opportunity. It was really great experience for robotics. And then in the judging, the design judges, they really love to see that kind of thing because you're actually validating your engineering design, which is the whole, engineering process. So this club was ready to go basically, and I was ready to go. So that's why I chose Baja. I didn't know a thing about cars. I taught myself everything I know about suspension from reading books in this club.
So your internship at Fox didn't involve suspensions?
It did not actually involve it involved suspension components, but I would say at Fox I was basically a glorified babysitter for a machine. The DMG Morisaki is a CNC machine that is absolutely incredible. It spits out 200 parts in 8 hours. All within, 5,000th of an inch of each other in tolerances. So I just sat there and I pulled parts off a machine and I made sure they were measured, they were within specification, and put them in a box. So I didn't actually do a lot of design or, work like that, but it really was a good opportunity because it made me realize that I don't want to be in a machine shop environment,
Right.
It's really great for some people. And I really like the hands-on work of it. It was a lot of fun. But Machine shop hours, I wasn't that interested in. I worked from 3 to 11 every day, and you know, it just wasn't what I really liked. So that's the great thing about internships. You go out there. It's really hard, at least for me, it was really hard to know what I wanted to do, but it was really easy to know what I didn't want to do. So I just went around and eliminated everything I didn't want to do, and what I was left over is what I wanted to do, and that was robotic engineering. So having internships like that and that kind of experience really allowed me to know that, you know, I'm not so much interested in being in a machine shop every day, even though I thought I was originally. After doing that job, after doing that internship, I was not interested.
And did you get them to sponsor your group?
So Fox actually is a sponsor of the SAE Baja is what the program is called, and they're a major sponsor, and so they sponsor the event per se, but they also give discounts on. Let's see if I can find so these are suspension components, the Fox suspension. So they give discounts on parts, and that's why we were able to get do this. We have to do all our own fundraising and get our own parts, get all our own material, etc. Some teams like Michigan, there's a Ann Arbor, Michigan team that is sponsored by a lot of the companies in Detroit, like GM and Ford, and they have a lot of money and they get really good stuff. So we were lucky to be able to get some gear from Fox.
Did you go straight from Chico to Omron?
No, actually, I went to a little company called Contour Motion before, and I actually did that right out of school. So one of my last semesters, I had an introduction to machine automation, or like basically motion control, and was working with motors and stuff. And a guy that makes motion controllers he came up and he did a class for us one day. He showed us how to use his motion controllers and stuff like that. And after class, I was the only person that went up and thanked him for coming up. You know, here's a guy that's coming up from San Jose, taking his time as a private individual, and is showing us his product, right? And so I went up, I shook his hand, I thanked him after class, I got his number, and we stayed in touch. I invited him back a few months later to our senior design program, our showcase. And he did an interview on the spot with me right there, and then offered me a job right there. So by the time I graduated, a week after the senior design showcase, I had a job offer in hand. It was really great. So having connections like that, just anywhere, knowing your teachers, being connected to the industry, being connected on LinkedIn, is where opportunities are going to come from, right? And that was a very small one-man organization, and I wasn't that interested in being in that small of a company and wearing that many hats. And so through people I met at Chico, through friends I had at Chico, they were friends with other people who worked at Omron and knew this position was coming open, right? So I connected with them. They let me know. I sent out a resume. I got hired at Omron.
Wow.
Again, it was all about just networking and who you know, right? A lot of my friends put out 50, 100 resumes and contacted every single company they could. And they got really good jobs because of that. They really got to pick what they wanted, R&D at Qualcomm and stuff like that. So, but I didn't go that route. I kind of laser focused and just went for exactly what I was interested in. I got it, and I was lucky to do so. Right now is a great time to be an engineer. We're basically like currency in the Silicon Valley.
And do you find that you use a lot of what you learned in school on the job?
Not as much as I thought I was going to do. Really, the mechatronic degree program at Chico was really focused on control systems, motion control, a lot of design, a lot of engineering and stuff like that. And unless you're on a design team or an actual engineering team, like application development, I use a lot of my background knowledge, but I don't write formulas every day. I'm not creating control stability graphs and stuff like that every day. So, but I use a lot of my background knowledge to troubleshoot the robot, right? So when a robot's not behaving in a manner I think it should, I can go back to my knowledge and say, why do I think this robot's not behaving in this manner? Is it the control system? Is it something to do with the hardware? Is it the code? And so, while I don't use the exact, I'm not going to use Laplace transformations every day. but having that knowledge helps me troubleshoot robots. Yeah, definitely.
Cool. I think we have time for one last question. If there's anyone in the class that wants to ask a question.
I haven't been monitoring the chat, so I apologize.
The question in the chat was the transfer process smooth? I think that was when you were talking about transferring from Cabrillo to Chico.
Transfer process was real smooth. I don't remember, Pretty, maybe you know the transfer website.
I think Joanne went through it with them. Yeah, so the other question we have, if you could go back in time and give yourself just one piece of advice, what would it be? And it's from Johnny and his wife. And the other fun fact is Aaron and Johnny's wife, I think, went to school at Cabrillo together.
Yes, we did. Yes, we did.
Yeah. If you could go back in time and give yourself just one piece of advice, what would it be?
Don't wait so long. I thought about this move for a while. There was nothing, I wasn't sure. I was, uncertain. I was hesitant. I was coming from business and I was like, do I really have the skills, the math skills, the engineering skills, the physics skills to become an engineer? And like I said, I didn't pass all my math classes right away. So just through sheer hard work and perseverance, I was able to make it. But if I were to give myself one piece of advice, it would be go faster, go harder.
Cool. Yeah. Johnny, we should ask you the same question. You and Issa both. Right back at you.
Oh, no. More networking. That would be mine.
Good one.
My wife has shown me just how good she is at it and how much I lack that. And I just trying to network whenever possible, wherever possible. I
think people find networking really hard. Like how can you, if you're shy or you're not outgoing or you're not, if it's not in your toolkit already, what are some ways you can network that don't feel like you're going to walk into a room where you know nobody and you're going to be a fly on the wall?
That's a really great question. When you're on campus, don't leave campus to go home and study. Go to Mesa, go to the STEM Center, if you can be on campus. I know right now it's difficult, but study groups. Study groups are a great way to surround yourself with people that you're in class with every day. One really good networking suggestion I have is try to know the people, especially when you transfer, try to know the people that are one semester or 1 year ahead of you, right? And this is why clubs are great, because in your classes, everyone's going to be at the same level. But if you get into a club, you're going to know the people 1-2 years ahead of you. They're going to graduate first. They're going to get jobs first. If you stay in contact with them, they're going to know about the jobs. And they're going to be able to help you get hired. I actually, Sam Muse is another Cabrillo graduate who a year later transferred up to Chico a year after I did. So, he was like, hey, how do you like it at Chico? I love it here. He made the move as well. And then after I graduated, I stayed in contact with them and I knew that, hey, my company's hiring. My company's offering hiring bonuses to people who get other people jobs here. So I said, hey, Sam, are you looking for a job? Send me your resume. I gave that to my hiring manager. He got hired. I got a nice bonus. And so knowing the people that are a year ahead of you is really great networking. I was really shy too before I came to Cabrillo. One of the things that really helped me at Cabrillo was I actually got onto the student senate at Cabrillo. I was a student senator for 2 years at Cabrillo. I started the robotics club as well. So if there's something out there you want to do, find a way to do it. I didn't have a lot of money to buy Arduinos when I was younger. And Cabrillo did. They had money, and I knew that they would, provide money to the club to purchase devices, and then we could learn together and teach each other together. Be nosy. Be really just, if you're walking past the lab and you look in and you see, hey, that looks really cool. Go in and say, what are you guys doing? This looks awesome. How do I be a part of this? And so that's one thing that maybe I was too nosy sometimes, but that's one thing that really got me a lot of connections was, what are you guys doing? That looks really cool. Just that simple.
Yeah, interesting. The class is curious about what you did before engineering studies.
I was in finance. I was in mortgages and finance, and so it's a completely different field.
Yeah. Yeah.
Yeah, I wanted to be super wealthy. Thought finance was the way to do it.
Is engineering the way to do it?
Engineering is the way to do it. Yeah. I mean,
okay.
It's. Lisa said no.
No.
No way. It's not a bad way to do it. I do make pretty good money. I don't have a super long work day. They don't work me hard or run me ragged. So I'm enjoying it a lot. It's probably more money that I would have made. Except for sales, it's more money that I could make doing anything else, really.
Right. I think you have to love it. Whatever you do, you have to love what you do. Pick something you love. You'll be successful. You'll be rewarded. That's the key.
Yeah, at least something you really like,
Yeah. What's the name of the robot arm behind you again? And then I think we'll have to go.
So that is the Omron Techman collaborative robot. It's actually a co-branded robot. A Taiwanese company named Techman builds the robot for us, and then we put our brand on their software, basically.
So wait, do you go to China?
I was supposed to go to Taiwan. I was scheduled to go to Taiwan the first week of February this year, and that got canceled, obviously, due to COVID. So, but yeah, I'm actually learning Mandarin right now. Oh, that's another thing I could say is if you want to guarantee yourself a job, learn German or Mandarin. Okay, super popular in engineering fields, right? Yeah, a lot of German speakers, a lot of companies in Germany, or if you know that the company that you're really interested, has offices in a certain region and you want to live there or travel there, engineering is a great way to travel.
Yeah. We
have seven sales offices throughout the world in all different regions. So I could go to Chicago, I could go to Barcelona, I could go to Singapore, I could go to Taiwan, I could go to Beijing.
And does your company send you there?
They do. Not as much as I'd like, but obviously, travel's restricted right now. But yeah, I have a chance to go out. And then as an application development engineer, I also have a chance to visit customers and see actually how they're using their robots on site.
Oh, that's great. Yeah. Someone asked, what about Japanese as a language? And I think that'll be our last question. Japanese is good too?
Japanese is good too. A lot of Japanese speakers, a lot of companies. Engineering is kind of global, but I would say the main areas for engineering are German speaking, Japanese speaking, and Chinese speaking.
Cool. Thank you so much, Aaron. Thank you so much, Johnny. I don't know if Hector's still here. Thank you all for being here and imparting your wisdom on the students in this class. I think they really learned a lot. And it's so great to see Cabrillo grads, doing so much fun work. Isa, what do you work on? We didn't hear from you as to what you work on.
Oh, I graduated as a chemical engineer, but I ended up going to sales. So I'm a market specialist for Agilent Technology.
That's where she makes all the money. No.
Yeah.
So I can retire.
All right.
So I shared my LinkedIn profile with you guys. If anybody wants to connect with me, feel free. You can contact me at my personal email through LinkedIn. So if you have any questions in the future or just want to stay in touch, go out and get some beers. I'm happy to do that.
Awesome. Thank you guys. Have a wonderful evening. We really appreciate you taking the time to speak with us.
Thank you. That was fun.
Yeah, thank you.
Okay.
Bye, everyone.
Bye.
Great. Well, I hope you got a good sense of some of the work that your Cabrillo alumni are doing in the field of robotics, which is really exciting. We are going to take a little break, but before we do, I want to introduce to you the project we'll be working on when we come back. And I want to do that so that you have an opportunity to grab all your stuff. And it looks like, hold on, this is section 2 or 3. Okay. To grab all the materials that I asked you to get. So I want to go over that. Let me just bring up the website for today. Let's see where we got it. Okay. And I'll share my screen in a moment. Screen. So we're going to end class today with a project. And this is, a format I think you guys are all used to. And today we're going to work on building a robotic hand, essentially. So it follows really well what we've been doing, and we're going to take a little extra time to do it because it's a little bit more involved. This page is open on this week's module in the Canvas site, so you're welcome to read through the information I've posted here. This video is really quick, and I encourage you to watch it. It's about using a 3D printer to produce a prosthetic hand for an 8-year-old girl. And so, in the context of that, which we had talked about before our speakers as well, let's now have a little fun building a hand that can pick up some objects lying around our house. So again, there's a lot of information here that I'm not going to go through, but what I did want to get to is that I'd like you to use stuff from around your house. And I told you in my announcement about group 1, group 2, group 3. So group 1 was items that I thought would be really useful for creating joints. Group 2 was items that I thought would be useful for creating tendons. Group 3 are items that I thought would be useful for gripping. And group 4 were things that I thought might be useful for using as fingers. You'll probably also need some sort of adhesive like tape, a glue gun, any kind of glue. You can sew, any kind of tape. You'll probably need some tools like scissors, or depending on what you picked in these groups, maybe, this kind of stuff. You can also use paper clips, cardboard, which is up here, what might be useful, and then some things to pick up. Some things that you might want to try picking up. So I listed a few things here, and you can just look around where you're sitting and try to pick something up. In front of me, I happen to have this dry erase marker. That might be kind of fun to try and pick up. We have a mouse that I'm using for my computer, things like that. Some things are light, some things are heavy. What's the heaviest thing you can pick up? That would be the goal of this project, is to build a little hand that you can manipulate to pick things up. So I have some questions here about what you might want to consider when you're considering this project. What do you want to do? Do you need 5 fingers? How many fingers do you need? What kind of items do you want it to lift? If you only want it to lift round items, then the design might be a little bit different than if you wanted to lift rectangular items, or maybe not. And then you guys I'll put you in groups so that you can bounce ideas off each other and kind of help each other along with the materials you have, or give ideas to each other. Everybody's going to have a totally different hand that they develop. And we're going to come back and you're going to show us what your hand can do and show us how you use some of your materials. And then to follow up on this, there is a discussion board post where you can reflect on your design. And some of the questions from here that are listed here are in the discussion board post, as well as just a wrap up of our speakers and what you learned from them. So that's also been posted and available if you want to look at that as well. So what I wanted to do was say, let's take a break now, and give you an opportunity to collect all that, take a moment away from the Zoom, stretch, and then we'll come back at, I guess, 5:30 and get started on the project. Any questions? Okay, so then I will see you in like 6 minutes or something, and we'll get started. Okay, so the announcement that I have before we started on the project is that you all are working on the Mobile project, which was introduced last week. I think Carl talked to you in depth about it. And on the last day of class, we like for a few people to present their mobile projects. So we are looking for volunteers. And I'm not going to ask anybody to volunteer right now. We're going to create a place for you to sign up probably next week, next Thursday. So this is something to think about if you would like to be a volunteer. We won't be able to accommodate the entire class. In fact, both classes will be brought together for the last session that we have. Both section 2 and section 3 will be together. So probably will take around 6 to 8 volunteers to present their mobile. And this is for extra credit. So if you have missed assignments or quizzes or, any of the discussions and participation, if you have a borderline grade, this may be something you want to volunteer for to get a few extra points. So if you're right on the cusp of a B, but you have a 79%, this might be what you need to get a 80% and get a B in the class. So think about that. And when we meet again next week, we will open up a sign-up page. And if more people sign up, then we can accommodate. We will just let the people know who we will have speak versus those who can't. We won't be able to hear from everybody. I mean, we're thinking really 6 to 8 people from each section can present. So I just want to put that out there for you all to think about. That is the only announcement that I have. Are there any questions on that or any of the projects or anything?
This extra credit opportunity is listed on Canvas?
No, not yet. It'll be listed next week. It's just something to think about for now. Okay. So I think there are, I don't know, 16 or 17 of us. So we'll have 5 breakout rooms. Actually, I'll create 6 breakout rooms. No, 5. Okay, 5 breakout rooms. And let me see how that works out. Yeah, I think that's okay. So 2 of you will be, unless there's, I felt like there were folks who had signed in on 2 devices. If you are on 2 devices, can you tell me?
Computer again. So
you broke up when you were speaking, so I didn't hear what you said. Okay, so nobody is on 2 devices. Everybody is on 1 device. Is that correct? Okay, I'm going to assume that's correct. Okay, so then I have 6 breakout rooms, and most of them have 3 people. I'll give you 1 hour in the breakout rooms to work on your hands. And, you know, we did this project in the other section last week. They actually only had 45 minutes to work on their hands. And it was amazing what they came up with. But it was a reality that there wasn't necessarily enough time, but that's okay because you can continue to work on it after classes ended. And, you know, and we can talk about your project after you come back and you can present to us what you've done. So by no means do you have to finish this in this time. And by no means do you have to use only the materials that I've listed there. It's just things like that that may be useful to you. If you have questions when you're in your breakout room, you're welcome to submit them over to me or ask me to come to one of your breakout rooms, and I'm happy to do that. If I don't get to you right away, it's because I'm with another group. So I do see all of the requests, and I will get to them in the order that I get them. Okay. So I'm going to open all the rooms unless there's any questions on anything. Okay.
So we're all individually building our own hands, right?
Yes, you're all individually building a hand, and you will all individually submit to the discussion post. I got a lot of feedback that people weren't happy with group discussion posts, especially when some group members didn't follow up on what they were supposed to do. So we're all going to just do individual group discussion posts with your own hand. Yeah, and you're all at your own house and you have your own materials, so it's fine. But you'll work in groups to help each other. You know, hey, this isn't working. How can I? Any ideas on this? Or I have this. What should I do with it? Kind of thing. Okay. Okay. So have fun. This is supposed to be fun, you know, and give you an idea of making something that actually in the real world is being made. Francesca and Amelia.